Sir, shall we start the session?
Okay. Hello everyone, I am Suprakash, Research Scholar, Department of Electrical Engineering, IIT Varanasi. Let's start the today's session. This question, first question, from the diagram given below, find the value of V out. We have to find the output voltage. This voltage connected this one to ground voltage. It means voltage cross the 3 kilo ohm resistor. How can you find this one? This voltage is given as V1. It means 3 volt. V1 is 3 volt. Here this current is flowing like that. The same structure, it means current is flowing. This is the open circuit, then that's why there is not current flow. This is current 0, then whole current is flowing through the ground. After that is flowing through this ground. Current is like that. Okay, this current is 0, that means this current is passing through like that. V out. Then it is asking the voltage across this. It means this current is flowing through like that. Then V out, voltage cross this resistor. It means this is a negative terminal connected to the V out, and positive terminal, it means negative of 3 kilo ohm into current 3 V1 milliampere. This is kilo ohm, this is milliampere, cancel out kilo ohm milli. This is minus 3, this is 3, and V1 is 3 volt, because this V1 is directly across the voltage source. It means this will be minus of 27 volt. Same thing if the direction is reversed, here the same value is the value is same, but the sign will be changed. It will be a positive sign. V out will be positive, but in this case this is the negative V output. Okay, same the next question, find the resistance of R1 R2 for the system below to work as the ideal voltage source, voltage controlled voltage source, and voltage controlled current source. This is, this is the voltage source. Sign of plus minus is the voltage source. This one is controlled by this V1. V1 is the voltage. It means this is the voltage controlled voltage source. What about this one? This is sign is current source, but same thing is controlled by this voltage, and this is known as the voltage controlled current source. Okay, it's one the value of this resistor, voltage source resistor, and value of this current source resistor. No, in the ideal case is this is the voltage source, this is the R, this is by terminal voltage. Any voltage source have some internal resistance which is shown in here. R this is the voltage source. Voltage source like a battery. Battery have a some internal resistance which is connected in series. The representation of that internal resistance is series with the battery. Because this is the voltage source, it means this is the drop at the terminal of this one. Suppose current is flowing high, I, then Vt is V output minus of I into R. This is the voltage drop because of the battery internal resistance. Suppose there is an ideal battery. If there is an ideal battery, then what is the resistance? This resistance. It means there is no voltage drop. No voltage drop. It means this resistance will be zero. Vt is equal to V naught. It means this is the zero. It means at the voltage source, the resistance, internal resistance will be zero in the ideal case. Same thing is asking in the question, is the ideal voltage control voltage source, then what is the value of R1? Then R1 will be 0. 0 is given two option. Here is R1 is 0 for ideal case. Same thing if you have a current source, is a terminal, then there is a resistor, the resistor which will drop some current, amount of current. Here suppose same thing, if I take a resistor in series with a current source, then what is the current here? Is the same I, because there is no current, any current drop here, because this resistor is in series with current source. That's why this representation is not correct. If there is a practical current source, then there will be some current drop. It will be IR, and this current will be I minus IR. Some current drop here, and that's why this representation is correct for the current source. This representation is for the voltage source. If there is a practical voltage source, then there will be a internal resistance. Same thing in current source, there is a internal resistance also here, but is connected in the parallel with the current source. Here the voltage source, the resistance will be connected in series with the voltage source. This is the practical case. If in what condition the current is fully passing through it, all the current passing through it, this current will be zero. Which condition? In condition this R is not available. It means this will be looks like in this case whole current is passing through like that. Then what is the resistance between them? It will be infinity resistance. Infinity resistance shows in the open circuit, and zero resistance showing the short circuit. Okay, it means here the internal resistance will be infinity for the current source. That's why R2 will be infinity, R1 will be 0. R2 is infinity, R1 will be 0. Okay. This is the voltage source and current source, practical and ideal. Okay. The next question: find the equivalent series equivalent resistance between point A and B if the each side of the cube has a resistance R. Asking the resistance, equivalent resistance between this terminal.
Nancy. Ashere?
Yes, Dilip, have any doubts? Okay. The question asking this cube have every side, each side have some resistance R. It means this is resistance, this resistance, this is have resistance, like that. Every side have some resistance, which will be R. Okay. Then what is the equivalent resistance between these two terminal? We have to find. Okay, same thing we will draw here. This showing a resistance at each one resistance.
Here we need to use Wheatstone's bridge concept. Am I correct?
No, no, the Wheatstone bridge apply. There are only five resistance, but
So
they
what
are
I want,
they are not connected to anywhere. Some resistance is connected parallel, series not. Can't say directly.
no, what I want to say is that A and B terminals are there. To the
Yes,
left of that face, we can give some names. Let us say C, D, E, and F,
yes, yes, yes,
and then the product of cross arms are same. So those two terminals are short circuited, something like that.
yes,
C, D,
yes.
E,
You
and
can
F.
do like that. E, F, G, H.
So here, can we say C and E are short circuited?
C and E.
Mm.
No, no, can't say like that. Short circuit it means there is a zero voltage. Na? Short circuit it means there is zero voltage. There is zero potential difference between two terminal. If the same voltage appears in that terminal, E, then same voltage appears also on the C. After that you can short circuit C and D.
Uh,
Only short circuit can happen where the voltage is same point.
but if the product of cross arms are same, no current will flow through C and E. If I connect any resistance or something like that, no current will flow through C and E. Am I correct?
Yes, but how can you find?
If no current will flow through C and E, then the potential will be same at C and E.
C and E.
Uh,
So first of
because
all,
if you
first of
consider
all,
the
first of all, you have to find the current direction. If there is a zero current flowing between them, then you can short circuit, no problem.
I think the product, if we take CF resistance multiplied by DC resistance, it's R square, and DE and CF, if we take the product, it will also come out to be R square. So since the product of cross arms are same, the bridge is balanced.
Bridge actually looks like that. No. If there is a possibility like that, then you can say these two are same, these two are same, there will be no current flow. Okay. But if suppose there is another resistance here, another resistance here, then you can't say directly. Same thing happening here. There is nothing any two terminals connected directly to resistance.
Okay.
That's why you can't say directly there will be a bridge resistance.
Will we
In
go for star to delta conversion?
same thing problem also there. We have to find the equipotential point like that. Suppose there is a positive terminal A. Suppose this is a positive terminal, this is a negative. Anything you can take positive, negative. The positive it means current flow like that from I, current flowing in three direction. In this case, okay, it will be visible for all current flowing in three direction. Okay, same current is goes to here and divided into two. This current and this current. Same current flowing here divided into two part. This current and this current. It means two current is flowing here and two is incoming current and one is outgoing current. Same thing here, two is ongoing current. Okay, here two is the one single is incoming current and outgoing is 2 D point. Same current is incoming, outgoing current is 2 because all of this symmetrical to each other. Then you can say the same current is this one is this current, all of it the same current because all is the symmetrical in the case. Then this direction you can say this point and this point have same potential because of the same current. Single current is flowing from A to G, A to D and divided into two part. Divided into two part. The opposite corner of these is the same point D and G. I remove this one. Suppose D and G have same point. Okay. There are two terminal A and B. A, B. N two terminal, we got this one. D, G have same terminal. Then look the negative point. Current is coming from here, from here, from here, and leave from here. I. Okay. This current flowing from this one. Same this current flowing from this one. It means this is current is incoming current, also incoming current from here. From here divided into two parts, this one and this one. This current, it means at B point in to coming to B point, this the current is incoming current is two part and outgoing is single. Same thing, incoming is two part, outgoing is single. That's why C and H have same potential. D and G have a positive side. Same thing, C and H have a negative side, it means B side. Okay. Then after there is a two terminals remaining, E and F. E terminal, E and F. There are the four terminals. We got the four terminals. And we have to connect the resistance according to the this cube. First of all, A to B have a resistance. Okay, connect them. A to B have resistance R. All have same resistance R. That's why written as R. Okay. Then after DGA is there. Then D to A have resistance and G to A have resistance. There are two resistance connected. G to A have resistance and D to A resistance. DG same point, then there is a two resistance connected to A. D to A and G to A. Same resistance R and R. Right, CH here. Okay. Same thing do for the negative side. C to B have resistance, C to B have a resistance, H to B have a resistance. That's why there is also two resistance here. C to B have resistance and H to B have resistance. This is the B terminal. We have to find the resistance here. Okay. D to C have any resistance? D to C have a resistance and G to H have resistance. G to H. It means there is also have some resistance. D to C have resistance or a single resistance. Okay. Then G to H have resistance. R and R. The remaining E is there. E terminal connected to D and G. D and G have same terminal. That's why there is also two resistances here. All of these are connected to each other. Same thing F. F have connected from two, C and H. C and H. C and H. That's why there is also two resistance. R, R. And then after E and F. E and F have a resistance. E and F have single resistance. You can see here E and F have a single resistance. That's why we have connected to single resistance R. These are not two resistance between them. This whole circuit is looks like that. If you find the equipotential, then after you can draw same circuit like that. Then after you can draw the circuit, resistance R here. Then after two resistances here in parallel. Then equivalent of this one is R by 2. This two resistance also here. Equivalent of this one is R by 2. Then after two resistance is here. So also R by 2. Then this is the also two resistance R by 2. This is two resistance R by 2. There is a single resistance here, terminal A and B. Okay. Same thing you can solve this one. These two connected in series. R by 2, R by 2. It means 2R. R by 2, R by 2, 1R. And this is 2R. 2R and R by 2 is connected in parallel. Terminal A, B, this will be R, R by 2, R by 2. This is R and this is R by 2, R by 2. It will be 2R. And this will be R by 2. Then R by 2 and 2R is connected in parallel. Same thing written here. You can solve this one. Find a single resistor. Then after this will looks like that. A, B, this will be R, R by 2, R by 2. And solve this 2. What is the equivalent resistance? 2R into R by 2 divided by I, 2R plus R by 2. This will be 2R by 5.
5.
2R by 5. Then after these 3 are connected in series to this parallel combination. This will be R, A, B. This all connected in series. It means R by 2, R by 2 is 1R. This will be R plus 2R by 5. This will be 7R by 5. Then what is the final resistance? Terminal A to terminal B. These two are connected in parallel. Then R into 7R by 5 divided by R plus 7R by 5.
7R by 12.
This will be 7 R
R by
by
12.
12. The final RAB is equal to 7 R by 12.
So can you please explain again why that T and G point and C and H points are same?
Okay. Because all the point have a symmetrical to each other because of all the connected to each other. Okay. Then you have to find the current. The same current is passing to two terminal. then both terminal have a same voltage drop. That's why I have taken as the same potential. Okay, this is current is positive terminal A, divided current going passing through all three is the same current, because of the all are connected to each other. That's why all of the same current. The same current is passing, flowing to that point, and this point is divided into two part. Incoming current is divided into two. Same thing at a G terminal. You can see here same thing, current passing flowing to G terminal and divided into two part. Then after this all meet to a single point E, one current. That's why this voltage drop and this voltage drop have same potential. Voltage drop is same, it means the D and G have a same potential. That's why I written as D and G have a same point. Same potential, it means same point. Same thing in negative side, a current is coming from C and H to B. Okay, but how the current is coming to the C point is in two part. Same thing, current is coming from two part here. That's why this negative terminal of C and H have a same voltages. That's why I have a equipotential. Equipotential, it means both are the same point. There is no voltage difference between them. That's why D, G and CH I have same point. Okay. Then after remaining part is E and F. E is connected to D and G. That's why you can written as a positive terminal. E is here, and the same F are connected to C and H is there. That's why we have written as F is here. And A and B have a starting point. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8 point. Same thing here, 1, 2, 3, 4, 5, 6, 7, 8 point is there. Then now you have to connect the register according to this cube. After that,
Okay. So,
yes,
if we consider point C and E, at point C, two currents are incoming and one current is outgoing.
yes, but both are the different point. Yeah, this
Right.
E have positive terminal, this C is negative terminal.
Mm, how we can identify positive and negative
Yes,
or
yes, yes. This below side have a positive terminal. This one, sorry, this have a positive charge. This will have a negative terminal.
okay.
That's why you have to choose the positive terminal from this one only, and same thing, choose the negative terminal from this only. Then we will get the exactly point.
Okay.
Okay, next point, consider an element whose VI relation is I is equal to V square plus 3B minus 10. Now find the voltage range where it will deliver the power. This is an element. Suppose there is a resistor, some voltage V and current. The deliver power, it means current it should be like that, outgoing from the positive, or you can say this resistor have always incoming from the point current from the positive terminal. What is the P? V into I is the power. But in this case, this is the source, sink, not a source. This element is not the source element, this is the sink element. In this case, suppose any element would, we don't know about this element, and current flowing like that, that element V into I. But this is the power sink, denoted the power sink because the positive terminal current enter to the positive terminal. What about the source? How can you deliver this one? Then it means this power should be a negative or less than 0 power. In this case, current, you can say the current direction is opposite or voltage direction is opposite. Both is possible in this case. That's why I am not mentioning exactly the which one is the positive and which is the negative. If the same thing, suppose reverse the direction of this is also possible. The case P is negative. Same thing, suppose this is the negative, this positive, current direction is opposite. Then both the direction is possible. The for the any element is there is power deliver, then P should be 0, less than 0. It means in this criteria, if there is a V, I, if there is in this region, I have a voltage positive, current positive, this means this is the sink, like a sink. And if there is a current voltage negative, current positive in this area, this will be a source. It's possibility. Anything you can reverse. Okay, that means the power should be less than 0. Okay. Then what is the current is given and what is the power? Power is equal to V into I. Voltage is V, I is given, and this will be less than 0 for deliver the power. I is V square plus 3V minus 10, should be less than 0. This is V square plus 3V minus of 10. You can break this one, V square plus 5V minus 2V minus 10. Common V, this will be a V plus 5 and this will be a V minus 2. For which range we have to equal all of this. V is less than 0, V plus 5 should be less than 0, it means V should be less than minus 5. This will be V minus 2 should be less than 0 and V is should be less than 2. Less than 0, it means it goes to minus infinity. Then this is the less than 2, okay, but less than 5 also is there. That's why it should be less than 0 V and less than 0.5 minus 5. You can't say 2 because of 5 minus 5 is there. 2 is greater than minus 5. That's why you take only minus 5. It means the range is minus infinity to minus 5. For this one, it means same thing. You can say current is positive, the voltage should be negative for delivering the power.
No, sir.
Yes, yes.
Sir, actually, this question was discussed with another TA also, sir. There also we have same doubt, sir. Like, if a V equal to 1, sir, then it will be still the power delivering, no, sir.
B is equal to positive 1.
Yes, sir. Yes, sir. Uh, shouldn't we choose the higher limit as the for limits we take lowest limit and highest limit, no, sir?
Yes, but if there is a possibility between, yeah, this is the high na, high na, some point you should be less than 2. Sorry, voltage less than 2. It means you will get the between you in between minus point 0.5 minus 5 to 2 also you can put there. There will be possibility, but some point is not there. That's why there is a reason.
If
You
we
have to
substitute
there's a
v equal to one,
there's
sir.
not in there's a not option is there. That's why you can put the
Okay,
2
okay, sir.
less than 2. You can put the v is equal to 0 also. You will get the negative power. No, this is p is equal to 0. Sorry. You put the v is equal to 0, that's when p is equal to 0 is there.
If our option is given like minus infinity comma minus plus 2 means can we answer it like that, sir?
Yeah, yes, yes. There is possibility.
Yes, sir. Thank you, sir.
Yeah. Because an option is also given, the v should be less than 2. It will be less than 2 is the higher possibility to get the delivery power. The next question is given as find the value of R naught so that maximum power is dissipated in R naught. Also find the maximum power. And what is the R naught? R1 is given is 3 ohm. It means in this condition load is variable.
Answer A, sir. This problem was solved on Saturday.
Okay, 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 okay. Suppose the same case if R1 is variable, then what is the R1 for the maximum power? If R naught is fixed, here is R naught is variable. But in some cases, suppose R1 is variable, then in that case, what is the maximum power? What is the value of R1 for the maximum power transfer?
R1 should be same as R0.
R1 should be same as R0,
Hmm.
but it will have a little bit some critical. You can't say directly R1 is same as the R0. Okay, what is the power formula?
0, sir.
0? Yes,
Yes, sir.
it should be 0 for the maximum power. There is no power drop, na? If this will be 0, there is no power drop anywhere. All power is delivered to the or not in this condition. That's why there is some questions, but you have to find which one is the variable. If the load is variable, in that case, the load should be equal to the internal resistance of the battery or a source for the maximum power transfer. But if the internal resistance will can varies, then this will be as minimum as possible. If the 0 is there, then it will be 0 or as minimum as possible. In that case, the minimum voltage power drop is there, power dispersion. maximum power is transferred to the R naught. Okay. For this case, if you want to express this one I square into R naught, suppose current is I, then what is the current? Suppose this is voltage is V. The V divided by of R1 plus R naught. Then what is the power? V divided by of R1 plus R naught square into R naught. This will be V square into R naught divided by of R1 plus R naught whole square. For P max, you have to apply a maximum minima, then dP by d or not, it will be 0 by maximum power condition. What is differentiation of this one with respect to the R naught? This is a denominator first into differentiation of numerator B square. R naught differentiation is 1 with respect to the R naught minus B square into R naught numerator into differentiation of denominator. This will be differentiation of this one will be 2 R1 plus R naught into differentiation of this one will be 1 divided by of R1 plus R naught denominator square whole square. This should be 0 for checking the maximum minimum. This will be V square common. This R1 square plus R naught square plus 2 R1 R naught minus of this will be 2 R1 into R naught minus up to R naught
Sir,
square. Yes,
sir, B square by R1 plus R naught. How can, sir?
this is the I square R naught no, for the maximum mark the power in any register. For the power at any register is asking on the R naught value na. That's why the power of any register is what? I square into R. You have doubts in this one?
Yes, sir, I understood, sir. I didn't understand the derivative, sir. dp by, now I understand, sir. U by V we use it now, sir. D by dx of U by V.
Yes, 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 yes. U by V only. D
Yes,
by dx,
now I understood, sir.
U by V.
Thank you, sir.
This will be V square, it will be 0, it will be common. These two are cancelled out. Then R1 square, this will be R naught square minus 2 R naught square, it will be R naught square is equal to 0. Then R naught square will be R1 square, R naught is equal to R1. In this condition, R naught is should be equal to the R1 for the maximum power transfer. Okay. Then this will be a 3 ohm. R naught will be 3 ohm. Then what is the power? I think you can draw, estimate the power. This will be I is equal to V by R 3 is 6, V by 6 is equal to 36 by 6, it will be 6 square into R naught is equal to 3, it will be 108 watt, I think. Okay. Consider the circuit shown below. What is the energy delivered to the capacitor from 0 to pi by 2 seconds? There is a single capacitor supplied by the AC source. Asking about the energy. This one also solved by previous TA.
Yes, sir. 5 microwatts answer came, sir.
5 micro
What's, sir?
joule.
This one discussed by past teachers.
Okay, okay, okay. Then I left this one, or you want to solve by me also? This is simple integration. Know about energy. Energy simply integration of 0 to t of power. Power is V into I. Voltage is given. You have to calculate the current. Then I, you know, in the capacitor, C dVc by dt. C d by dt. Voltage given sin t. Differentiation of sin t is equal to cos t. And what is the energy? Is given 0 to pi by 2, asking the question. Voltage is sin t and current is C into cos t. You can take C common. You have to multiply up to here by 2, and this will be 2 sin t cos t. It means this will be sin 2t. Integration of sin 2t equal to minus of cos 2t divided by up to. We have to put the all value. This will be C by 4 minus of cos. Put the 2t in place of t pi by 2, it will be a cos pi minus of this minus will be positive cos 0 to C by 4. Cos pi is equal to minus of 1 minus will be 1 plus cos 0 is 1. This will be 2. It means finally C by 2. But the value of C is 1 microfarad. This will be 1 into 10 to power of minus of 6 divided by 2 equal to 0.5 micro This will be not watt, this will be joule. This is energy. Microjoule. There is not options.
Sir, we can convert micro into millijoule.
Yeah, you can convert. For conversion, this one 0.5 into micro 10 to power 6 and 0. This will be a milli. Or you can say this is known as millijoule, and this will be 0.000 plus this 0.40 millijoule. Is a total 1.3 point here, 4 point is there. 1, 2, 3, 4. Okay. 0.0005 millijoule. Okay. In the circuit given below, A1, A2, B1, B2, C1 are the bulb shown as the resistor here. Find which bulb will glow the brightest and which will glow the dimmest respectively. Rating is given. Then you have to find the which ones glow higher. All are depending on the power. Which one bulb is have a more power, it will be deliver more energy. It means this will be higher brightest brightness. If there is a low power is there, then there is a dimmest bulb. Then we have to calculate the power across the every bulb. There are three bulb. Okay. Find the resistance of each bulb. Then R A1 R A2 it will be same. We know about the resistance V square by P is equal to power is equal to I square into R V square by R. We transfer this one, then R will be V square by P. And what is the voltage of A1 A2? Voltage is 200 volt and 200 watt. Then this will be 200 square divided by of 200. This will be 200 ohm. Then what is the B1 B2? R B1 B2 same V square by P. The voltage is 400 square, power is same, 200. This will be 800 ohm. It is the RC1, same V square Vp, 100 volt square divided by 500. It will be a 20 ohm. Okay. Now place the R resistance across this circuit. Five hundred volt. This one A1, A2, C1. This one B1, B2. Other resistance of this one. This is a 200 ohm. This is also 200 ohm. This is 20 ohm. This will be 800 ohm. This is also 800 ohm. This is the 800, 200. This will be 800, 200. This is the bridge stone. Oh, it is. This is making the bridge. Wheat stone bridge.
Yes.
That's why it means this current will be 0.
Yes.
Then you can tightly say a PC1 power across the C1 will be 0. This is the dimest bulb because of 0 power there. If this is 0, then you can remove this branch. They remove this branch, then what happened? These two are connected in series across the voltage of 500 volt. This is divided between 2. And what is the current? 8 in 200. What is this current and this current? Both are connected in parallel to the source. Same thing you can write as like that also. Both are connected to parallel to the voltage source. The current, what is the current? V by I, V by R. V is 500 volt, R is 8 plus 200. 800 plus 200 is 1000. 500 divided by 1000, this will be 0.5
Fine.
ampere. This is also 0.5
Fine.
ampere. Then simply current is there. Then what is the power? P A1, P A2, 200 into 5, V I square into R, 0.5 square into 200. This will be a 50 watt. Same thing, 0.5 square into 800.
200.
200 watt. The maximum power is V and minimum power in the C1. Then V1, V2 is brightest and C1 will be dimmest. Okay. Calculate the power supplied by the voltage source.
Sir, in previous question, how did you determine the power in A1, A2? I square R.
Yes, yes, simply I square R.
So I is 0.5. ठीक है. ठीक है. Okay.
0.5 square into 200,
Okay.
50 watt. Just calculate the power supplied by the voltage source. This is a voltage source. Power supply, it means power is delivered by this voltage source. Then you can say current direction is this one. Simply let the current I, then after this is a 2 ampere current, this is 1 ampere current, total here is 3 ampere, and this is 3 ampere, this is 1 ampere. What is this one? I plus 3 ampere current, I plus 3 ampere, 1 ampere is here going to this one, and this current is equal to I plus 2 ampere. Same current is passing flowing through it also, and after this 2 ampere is going here, that's why this will be I is going to this one and I coming from this one. Then you have to calculate the I. How can you calculate? Simply apply the KVL in this loop. This current direction, this is positive, negative, this is positive, negative, this is also positive, negative, positive, negative. Apply the KVL, start from here of minus
Sorry,
10.
sir.
Yes.
How you said, sir? I plus 2, I plus 3. How it came, sir?
Okay. Are you not understand how can I
Okay,
written?
okay, go on, go on,
How
go
I
on.
written? Okay.
I got it.
Okay. I write again. This current I let from the source, which one I want to calculate. And this is 2 ampere is coming from here, this node. This 1 ampere is coming from this node. Then what is this current? 3 ampere.
Yeah, got
And
it.
this 3 ampere current and this I is coming here from here. Then 3 plus I, this one, I plus 3 or 3 plus I, anything you can write.
Yes, sir.
Then I plus 3, okay, but 1 ampere current is leaving from this one. Then
I plus 2.
I plus 2 ampere. After this one, 2 ampere is also leaving from this one. Then only I is from this one. Okay. Now you have to apply KVL in this loop. You can start from here, minus of 10 volt. Okay. Then after resistance is R1. R1 is 1 ohm. 1 ohm. This is also 1 ohm. This is also 1 ohm. This is also 1 ohm. Okay. Then I 1 ohm positive is there, plus 1 into I plus 3 plus 1 here into I plus 3 plus 1 here I plus 2 plus 1 here I plus 2 is equal to 0. This will be minus 10. This will be I plus 4I plus 3 plus 3 is 6 plus 2 is 10 is equal to 0. Then 4I is equal to 0. I is equal to 0. It means this source is current is 0. Power is 0. Power is equal to V into I. V is 10. I is 0 is equal to 0 watt. This voltage source is not delivered any power to this circuit. Only these two current source are supplied the power to whole circuit. Okay, this structure. If there is any resistance is changed, like 1 ohm resistor instead of any 1 ohm resistor, is there is any 5.5 ohm resistor is there, in that case this voltage source will deliver the power, because of that resistor is taking the more power. But in this case this will be current 0. Determine the power absorbed by the R2.
There were no option of 0 watt.
No option is 0. Yeah, this one na 0
Yes,
watt.
D. Okay.
Determine the power absorbed by the R2 resistors. This resistor R2 resistor, R resistance is given 10 ohm, 3 ohm, 4 ohm, 5 ohm. Okay, you have to find. How can you calculate the power? P is equal to simply I square into R. You have to find the current, this current I2. Then power is will be I2 square into 10 ohm, because of R2 is 10. How can you calculate this one? Wait, I write circuit diagram, bigger one.
We need to consider 3 nodes that on the middle.
6 ampere current, 4 volt, there is a resistor, then after there is a current source, then after there is a resistor is here, is a dependent voltage source, so 2I, this current is I, this is given as 3 ohm, R1 is 10 ohm, sorry R2 is 3 na, this will be 3 not 10, R1 is 10, R2 is 3, R1 is here 10 ohm, 3 ohm, then R3 4 ohm, R4 5 ohm, 4 ohm, 5 ohm. This current source is 5 ampere. Okay.
We can consider 3 nodes and apply KCL at each node. Leftmost node voltage is 4 volts.
This voltage is 4 volt.
Yes.
This voltage is minus 2I. This voltage is unknown. This is also unknown. Okay. You can apply a 3 nodal analysis or you can apply 3 mesh analysis. Mesh equation. You can take nodal here, but you can't. The current is given is here. I you can take directly current I here is 2I. Then you will get some equation here. Take this one as I2. Okay. Suppose this voltage is V1, this voltage is V2. I current flowing here. Then what is this current? 6 current is going here, and this will be I minus 6. After this current is meeting here plus 5 ampere, then what is this current? This current will be I minus of
Minus
1. Okay. All connected is the same point, negative point. You can say this is because 0 potential. And what is the V2 and V1? What is the voltage difference between them? V2 minus V1 in this case. I taken two equations. First of all, take a loop here, one loop. Second, take a loop one here, second loop. In loop 1, start cable from here, minus of 4 volt plus 3I2 minus of 2I is equal to 0. Three I2 minus 2I is equal to 4. Equation number first. Okay. Apply KVL in loop 2. This will be started from here, plus minus. This will be 10I. 10I. Then after this potential, this resistor, plus minus 10I plus 4I minus 6. This voltage across the current source is V2 minus V1 plus V2 minus of V1. This voltage V2 minus V1. Then after minus of 3I2 is equal to 0. This will be 14I minus 24 plus V2 minus V1 minus of 3I2 is equal to 0. Question first is question second. What is the V1? V1 is same. This is a 0 potential. This is a V1. Voltage negative connected to here. It will be 2I. And what is the V2? Same voltage drop plus minus 5 resistor and current. Voltage drop is 5 resistor into current. This will be 5 I minus 1. Same thing you can put here. 14I minus of 24 plus V2 is 5I minus 5. This will be negative is there. That's why this will be negative. Negative will be positive 2I. 3I2 is equal to 0. (14 plus 5) 19 plus 2 21I minus 3I2 is equal to 24 plus 5 29. Question number 3 here. Question number 4 here. 1. It will be minus of 2I plus of 3I2 is equal to 4. can simply add both. Then what is this one? 19i plus 0 is equal to 33. I is equal to 33 by 19. You can put the value of I here to find the I2. Minus of 2, 33 divided by 19 is equal to 4. 3i2 is equal to 4 plus 66 divided by of 19 is equal to, this will be 142 divided by of 19. I2 is equal to 2.49 ampere. Then what is the power at resistance to PR2? I2 square into R2, 2.49 square into R2 is equal to 3. It will be a 18.61 watt. Simple equation you can solve by taking the KCL and KVL. But we have to keep the strong calculation about that. We can take these two nodes also, taking the KCL as this node, also we will get the two equation. We have to solve. Okay. Calculate the power absorbed or delivered by the resistor and inductor in the below circuit at 10 t is equal to 100 microsecond. Consider L is equal to 1 millihenry and R is equal to 1 kilo ohm.
So please show me the answer of that previous question.
Options.
Yes, sir. Okay, sir.
I think this one 18.62 is correct.
Yes, sir.
We have to calculate the power. In this case, power from two elements R and PR and inductor PL. This will be I square into R. This will be V into I. It is asking about particular time. T is equal to 100 microsecond. At that point, what is the power from both element? First of all, calculate the I. What is the I? This point is minus of 10 milliampere. By apply the linear equation formula, this will be I is y axis, t is the x axis, then y is equal to y2 minus y1, y2 is minus of 10 milliampere, y1 is equal to 0 divided by x2 minus x1, x1 is 200 micro, x1 is 0 into y x minus x1, x1 is t, x1 is really 0. This 10 to the power minus 3 is minus 6, minus 3 will be cancelled out, this will be 0.2 minus of 10 divided by of 200 into 10 to the power of minus 3 t, or this will be a minus of 10 divided by of, or you can say this will be 10 into 1000, 10 to the power 3 is upward, this will be 200 into t, then this will be a minus of 50 t. This is the current. How to calculate? Okay, not means I think this will be PR register. This is the inductor. Per resistor, I square into R. I is minus of 50 T square into R. 2500 into T square into 1 kilo ohm. T is 100 100 microsecond into 100 microsecond, it means 100 square into 100 into 100 into 10 to the power of minus 6 into 10 to the power of minus 6 into 10 to the power of 3. We have to calculate all the 0 like that. Positive 0 and negative 0. Negative 0 is minus 12. Positive 0 is 1, 2, 3, 4, 5, 6 and 10 is 9. Into 10 to the power of minus 3 is remaining. It means this will be a 25 milliwatt. Okay. You have to count the 0, positive 0 and negative 0 and subtract them, then after direct them. Finally, PR. What is the PL? V into I. What is the voltage across the inductor? L di by dt into I. What is di by dt? This one. Minus 50. Inductor is 1 milli. 1 into 10 to the power of minus 3. I is minus 50. Di by dt is minus 50. And I is minus 50 into t. 10 to the power of minus 3 into minus is positive 2500 into t is 10 to the power of minus 6. So this will be 100 micro t. Total positive 0, 1, 2, 3, 4, negative 0, 9. 25 into 10 to power 9 minus 9 watt, but there is not option like that. This is a milli.
So from where minus 6 came?
Sorry. This will be 1 2 3 4 0 9. This will be minus 5, not 9. Sorry. 25 into 10 to power minus 2 into 10 to power of minus 3. 10 to power minus 3, it will be milli. Then this will be 0.25 milliwatt. 10 to power minus 2, 25 into 10 to power minus 2, it will be 0.25. Okay. First one, find the current equation by given the form. Then I have to simply apply the power I square R and V into I. Next question, from the below circuit, find the value of I1, I2 in option such that both 7 volt and 5 volt battery absorb power. There are many configurations possible, but only one of the given options satisfied it. What is means of this question? This question is say that 7 volt and 5 volt battery absorb the power. Then find the possible configuration of I1 and I2 from this option only. How can you find this one? This one absorb the power. It means there is some current going through it from positive. Some current is passing through it. I7, this will be I5. Let's try. This current is 12 ampere. Okay. 12 ampere of current is coming from this source, and is this node, the some current is going to the 7 volt so voltage source. Then what is this one? I1. In this case, I1 is less than 12 ampere. This is possibility. This will be. This is not possible. This is exactly. It will be less than 12 ampere. I1. Why? This will be 12 ampere current. Some current is going to the 7 volt. That's why I1, its first condition, I1 should be less than 12 ampere. Then after, there is some other case, some current is flowing to this 5 volt battery. That means this is the I1, this is the I2. It means I2 is less than I1, because of the I1, from the I1 some current is going to the 5 volt battery. That means the I2 should be less than I1. Now match the option. First, I1 is 3 ampere. Yes, it's possible because of I1 is less than 12 ampere. Then possible, but I2 is 5 ampere. In this case, I2 is more than 5 ampere. It is not possible for I. This in this case. That's why this is not correct. Second option, I1 is 15 ampere. Also more than 12 is not possible. C, I1 is 9 ampere. Yes, I2 is 5 ampere. Yes, also possible because of I2 is less than I1. I2 more than 12 ampere is not possible. Only option C is correct.
So once tell me why I2 is less than I1.
Because of the I1 have some current, but in this node 5 volt battery we have like a sink. This one absorb the power. It means some current is flowing through this. Then I1 minus something is I2. That's why I2 always less than the I1.
Okay, sir.
Yeah. From the below circuit, find the power absorbed or delivered by the 5 volt battery. This is the 5 volt battery. For delivered or absorbed the power, you have to find the current. Cross it. Current flowing through it. It will be positive current or negative current. Okay. How can you solve this one? If there is a voltage source or current source is there, voltage source is between two terminals. There is not resistance. Here is not any resistance there. In this case, follow the KCL loop voltage source, KVL in this case. Don't try to go for the KCL. You can't say this one is voltage V1, this V2 and apply the KVL or KCL in this case. If you apply, then what is the current is there? There is not resistance and not fixed voltage is there. And if you take the V1, V2 also, but there is a not short circuiting here, then you can't say this is the ground. There is another problem. This is not ground. Then you can't say this is a V2 voltage is in the KCL node. This voltage is same as the this voltage. For this you have to put this will be ground. But there is a 2 kilo ohm resistor. Can't be grounded this one. Ground is anywhere I don't know. That's why go for the KVL in this type of cases. KVL means simply take the current, let the current, this will be I1 flowing through it, this will be I2 into this will be I3 flowing to this, and apply the 3 KVL and solve this one, then we will get the final answer. Loop 1, loop 2, loop 3. First of all, in the loop 1, or this one starting from this one, minus 5 plus 5 kilo ohm. Actually here all the resistance in kilo ohm. Resistances are in kilo ohm, voltage are in volt. Then what is the current? Current is coming from milliampere. Okay, then don't try to write like a 5000 ohm. If the all are the same kilo ohm resistor, then don't try to write a kilo ohm like 5,000 or 1000. This is 2000 ohm. Simply take a kilo ohm only. Then you get the current in milliampere. That's the important. If there is the same thing, then current will be in milliampere. That's why I write directly. This will be 5 into I1. This is 2 plus 2. What is the current? This is the I1 minus of I2 is equal to 0. 5 I1 plus 2 I2 plus 2 I1. This will be 7 I1 minus of 2 I2 is equal to 5. Equation number first. KVL in loop 2. In second loop, same. You can start from here. Minus of 2 plus 2 minus 3 I2 minus I3, 3 into I2 minus of I3, then this one plus 2 I2 plus this one I2 minus I1, 2 I2 minus of I1 equal to 0. 3 I2, 2 I2 and 2 I2, 3, 2, 5, 2, 7 I2 and minus of 2 I1, minus of 2 I1 plus 7 I2 minus of 3 I3 is equal to 2. Question number 2. Then KVL in loop 3. You can same thing, start from this one. Anywhere you can start minus of 8, or you can start from 3. This will be 3 plus this terminal is first, minus of 8 plus 3 kilo ohm I3 minus of I2 plus 2 kilo ohm I3 is equal to 0. 3 I3, 2 I3, it will be 5 I3 minus of 3 I2 is equal to 5. Equation number 3rd. In a 3 equation, 3 variable, you can solve easily. You have to find the I3, I1, because in the question asking for the power delivered as absorbed by the 5 volt battery. Then we have to find the I1. For the I1, from the whole equation, find the I1, I2 in the term of I1 here. Same thing from find the I2 in terms of I3. Okay. Let's start from 1. What is the I2? 5. It will be 7 I1 minus 5 divided by of 2. From this one,
Excuse me, sir.
yes,
Sir, in loop 2, minus 2 is there, then plus 3 I2 minus I3 is there. That is okay. Then the 2 I2 is which one, sir? The down 2 kilo ohms.
yes.
Okay, there only I2 will flow, sir.
Only I2 is there na in this branch.
Okay, that way.
In
Okay.
this branch I have two current, but in this
Okay.
branch is only I2. Okay. From here Find the I3 in terms of I2. What is the I3? I3 is equal to 5 plus 3I2 divided by of 5. Okay. Put this I2 value here. Then what is the I3? 5 by 5, 1 plus 3. I2 is 7 I1 minus 5 divided by of 2. This will be a 2 plus 21 I1 minus 15 divided by of 2. It will be 21 I1 minus 13 divided by of 2. There is I2 and I1. Yes.
There 5 will be there, no, sir? In I3,
I3 is
1 plus 3 by 5. 1 plus 3 by 5, sir. In from 3 on, next. I hear, sir. 1 plus 3 by
okay,
5
okay,
will be
okay,
there.
okay, 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 okay. Thank you for this. This will be 10. This will be 10. Then this will be a 5 by 10. Okay, sorry for that. Put the values of I2 and I3 in second. There will be 2 minus of 2 I1 plus 7 I2. In terms of I1 is equal to 7 I1 minus 5 divided by 2 minus of 3 I3. I3 is equal to 21 I1 minus 5 divided by of 10 is equal to 2. This will be minus 2 I1 plus 49 I1 minus 35 divided by 2 minus this will be a 63 I1 minus 15 divided by of 10 is equal to 2. Take a LCM of 10. This will be minus 20 I1 plus this will be some 5 49 into 5 2 45 I1 minus 35 into 5 175 minus this will be 63 I1 minus of plus 15 is equal to 0 sorry 2. This will be a 245 minus of 63 minus of 20 162 I1 minus 175 and minus of 15 160 is equal to 20. I1 is equal to 180 divided by of 162. This is 1.11 ampere. Your I1 is positive. I1 is positive, it means this source is the deliver the power. Okay, because of the current is leaving from the positive. And what is the power? Power is equal to V into I. Voltage is 5 into current is 1.11 is equal to 5.55 watt deliver. Why deliver? This is the current is leaving from positive. If same thing, suppose in your calculation this current will be negative, I1 is minus 1.11, it means your observation is wrong. This current is flowing like that, negative. It means current is enter from negative. That's why this source is react like a source, a sink, not a source. In that case, this will be absorb the power. When the current enters from positive, that's time the source is absorb the power, not supply the power. But in this case, the current observation is correct, and I1 is outgoing from the 5 volt of battery. That's why the power is delivered. This was not correct. This one correct. Okay. From the below circuit diagram, find the current Ix. This current, if the V1 V voltage, these two are 1 volt, and these two current source is 1 milliampere, and all resistances are 1 kilo ohm. Then what is this Ix? You can't apply the Bridgestone bridge, sorry, Wheatstone bridge, because of there is also resistor here. In this case, if there is not resistor, this is short circuited, then you can simply apply. Okay, then how can you find? It is given that use superposition. You know about superposition theorem? It means remove all the sources, apply only one at the time, then find the current of Ix, then after apply the second one, remove the first one also, then find the current, like that. And it means you have to 4 circuit or this one. First one, this one, take this one, then after this one, then this one, then this one. Okay, I take first one, B1, B, this B. Then what the circuit is there? This is removed, this is removed, this will be short circuited, open voltage source will be short circuited, current source will be open circuited. This is the open, this is open, this will be short. If this is short, then this there is not meaning of anything of this resistor, because of this is the short circuit, all the current is flowing from this one, not this resistor, because of the current is follow the low resistance path. This is resistance is 0, this is the 1 kilo ohm, then how, why the current is flowing through it? All the current is flowing through it, that means this is the also short circuit, not meaning of this. The no circuit is this one only. This is the voltage source, this resistor, then after this resistor, then after this resistor, and this is the short circuited. The circuit looks like that. is 1 volt. This is all 1 kilo ohm, kilo ohm, kilo ohm, kilo ohm. And we have to find Ix. This current is simply 1 volt directly proportional to this resistor. 1 divided by 1, this 1 milliampere is current flowing through it, not meaning of this one. Then we have to find this current. This voltage is same as 1 volt parallel connection. Then what is the current of this one? Calculate all the voltage source, sorry, all the resistor, equivalent resistor. Then after divided into 1, and we get this current I. All the total resistor, this resistance are connected in series. 1, this is 2, connected in series with the parallel of 1. What is the overall? 2 by 3, 2 by 3 plus 1 plus 1. Its total resistance is I is equal to voltage is 1 divided by total resistance 1, this one 1, plus this combination is 2 parallel as 1 is equal to 2 by 3, 1 divided by f. This is 1, 1, 2, 6 plus 2, 8. This will be total 3 by 8 milliampere. Then what is the Ix in this case? I written as Ix here. Ix1 here. First case 1. This current is divided into two parts. This part and this part. Both are the same potential. That's why these both are connected in parallel condition. That's why if you want to find this current, then total current into opposite resistance. Opposite resistance is 1 1 1 2, and divide by up total resistance 1 2, this here and 1 here is 3. This will be 1 by 4, 0.25 milliampere from this voltage source. After you have to apply this voltage source. Okay, then this will be short, this will open, this will open, this short, it means this is also short. Okay, then the remaining part is this one.
It will come same, I think.
It will come both circuit is same,
Yes, sir.
looks like same, simply opposite of this one, but circuit is really same, the same circuit. Then what is the current? Ix2. This is also same, 0.25 of milliampere. Because both circuit is same, this one. Okay, two sources completed. Then what the next? We have to apply this one. Okay, third one. Then this will be short circuited. This is short circuited means this is also short. This is short circuited. This is also short. This is removed. Then only this portion is there. One milliampere is there. 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm. Ix3. Can you say this is the circuit? Breeze. Wheatstone bridge.
So Ix3 is equal to 0.
In this case, Ix3 is equal to. Same thing you apply here. This was removed. This is the same, but circuit will be same. Third case, last case. In this case, this is removed. This is 1 milliampere. This also circuit same. Wheatstone bridge. That's why this also current is 0. Then what is the Ix? Ix1 plus Ix2 plus Ix3 plus Ix4. 0.25 milliampere plus 0.25 milliampere plus 0 is equal to 0.5 milliampere. If the question in microampere, then simply apply the 1000 here. Microampere current. Yeah, this one, last option. Okay, everyone. Okay, I want to stop here. Thank you to all.
Thank you, sir.
Thank you, sir.